you have questions, if you read the whole report later, or look at a figure and don't understand something, or a table, get the questions to Sarah or Doug or somebody, and they'll get in touch with me, and we'll figure it out, and get everyone on the same page. I appreciate the fact that it seems like most of the people on the lake are here, right? I mean, it's probably more than 50%, right?
Yeah.
Which is almost unheard of, and that speaks well of the group. It speaks well of the possibilities ahead to do meaningful things out here. I often will go to lake associations, and one prime example is Lake Winnipesaukee. Thousands and thousands of residents. They might get 30 people for an annual meeting. Not good. I mean, how are you going to fix problems with that? So the participation is so critical. And I this is kind of a message I often give at the end, but I'll say it now, and maybe I'll say it again at the end, is I am certain that there's something that everybody here can do to make the situation better. It might be a very small thing, but there's something that everybody can do, and it's just a matter of figuring out what that is. You might think it's a really, really tiny thing, like, fixing a gutter pipe that drains down into the lake, or something simple like that. Changing the way you maintain your property, not using fertilizer, using, whatever it is, there's something everyone can do, and it's just a matter of kind of figuring out what that is. So that's something to think about going forward. So when I did the first look, kind of the broad look at, what's Tucker Pond, what should it look like, and what would it be like but for the people here and the things that have happened in the watershed. And I think the water quality would be really good. The watershed is not that big. It's primarily forested, and I think without people here and without sort of activity, water quality would be really good. The advantage you have here is the watershed's not that big. And watersheds that aren't that big relative to the size of the lakes usually have a really good chance of being fixed. Because as things you kind of can see everything that's happening around here. There's not a lot of water coming down, and so there's not a lot of nutrients naturally coming into a lake like this. And most of the development is right around the lakeshore, if not all of it. And all those people are here. They're all at the table. So, you guys are in a unique position to really take charge of your own destiny here, and that's great. I think that's a really good thing. I think that this lake would look like what we call a nutrient poor or a clear water lake under natural conditions. So that's kind of the goal that you want to get back to. Kind of when it was like that. It hasn't been like that for quite a while, and most recently you guys have had cyanobacteria blooms that haven't been fun to live through. We're going to try to get you on a path where you can start to address some of that. And so you're in a place right now where they call mesotrophic. You're like in the middle. So there's oligotrophic, which is very few nutrients, not much greenness in the lake. There's mesotrophic, which is kind of a transition, and it can be green sometimes, it can be clear sometimes. Today it's clear, but it might be green tomorrow. You don't know, And then there's eutrophic, where it's green most of the time. That's a place you don't want to go, and that's lots of nutrients. We probably all know of ponds that are like that. I'm trying to think of one that everyone might encounter. Turkey Pond on Route 89, pretty green. Horseshoe Pond in Concord, pretty green. Those are more on the eutrophic end of things, and that's not a place that you guys want to be. All right, so I'm going to move forward a little bit. I'm just using this just to make sure I hit everything. So, cyanobacteria issues here are not new. I did a little research on some of the old data, and there was cyanobacteria reported in 1985. 97 there was a report of it, and a lot of that there may have been more instances than that. It just nobody was looking. Even back in 1938, you know, the state Fish and Game looked at the pond and said, you know, there's some oxygen issues, so we think this is only a warm water pond. That's a suggestion that maybe water quality wasn't great then. One thing that's kind of unique about a lot of our northern New England lakes is that water quality, I believe, and this bears out in some of the deep sediment coring that I've done in a bunch of lakes, was probably much worse before any of us were alive here, when there were no trees in the watershed. It was all forested, or all deforested, all cut for timber. I think water quality probably in the 1800s, when there was sheep farms everywhere, and was probably pretty poor. So we have that legacy to contend with, you know. And when people say, well, how good were the good old days? You know, we just haven't been alive long enough to know that they were bad before they got good again. And you know, back when some of the older amongst us were around, things were probably fairly good. Things have been forested for a long time here, and there weren't that many camps, and there wasn't that much activity, and things were probably pretty good. And now we're kind of seeing a little bit of a decline again related to development. But the legacy of all of that old bad water is still in the bottom of the pond. It's in the sediments, and that's where you want to keep it. You don't want that, all of those nutrients that are down there from a millennia ago to come back and visit you. So that's one of the things that we're concerned about with ponds like this. Let's see.
Those hills, Don, were all sheep pastures up there that
Yeah.
we look at.
Yeah,
Those
and
are
I'm
open
guessing
sheep
that
pastures.
it turns out that sheep make some phosphorus, and and they eat all the grass, so you end up with a lot of erosion.
Trees are all cut.
You know, and probably water quality wasn't great. You know, and that's just a fact of, you know, where we live. You know, thankfully that there's land out in the Midwest that doesn't have rocks, and all the farmers, once they realized that there was land out there, they said, well, that's it. I'm not farming rocks anymore. And they left, and they abandoned all the farm fields, and, you know, the water quality is to the benefit. So I'm not going to talk a lot about the tributary data, other than it's pretty variable. It goes up and it goes down, and a lot of that is related. So I'm on figures 3 and 4, and a lot of that is related to just when you happen to take the sample. It's usually pretty variable in a lot of streams, and until you get a lot of data in one year, where you can, you know, start to understand a little bit about what maybe caused a particular bad reading or not, it's kind of hard to make a lot of sense out of it with just, you know, one reading a year or 2 readings a year. So I'm not going to say a lot about that. There's nothing in here that you know, particularly recently, that's like hugely alarming to me. I mean, the concentrations over the last 20 years or so in the tributaries are pretty good. You know, compared to other systems I work on, they're pretty good. And part of that is because they drain areas that have nothing going on. And, you know, forest ends up absorbing almost all the phosphorus, and not much comes down. You just get clean water, you know, and so that's a good thing. I mean, you have a few roads, and you want to keep track of those. You know, they cross over the streams before they get here. But other than that, you know, I'm not going to say a whole lot about the tributaries, but keep monitoring them. And if something changes drastically, then, you know, start walking upstream and finding out what's going on. So in the lake, you know, your phosphorus concentrations are, in the last couple of years, around 9 or so. I'd like to see a lake like this below 8, and I think that's a reasonable target for you guys. You're not that far from that. And usually lakes that are below 8 for phosphorus don't bloom very often. And if they do, it's kind of just a quick blip kind of a thing. And that I think, you know, as a goal, when you get to the point where you're doing watershed planning and you need to find a goal, like how much phosphorus do we need to get rid of to get to 8, or to get to a goal, below 8 would be a good thing to shoot for here. And then, you know, it's kind of a thing of what we call adaptive management, where you go below 8. If you're still having problems, you rethink and you say, maybe we got to go a little lower until you don't have problems. But I think below 8, I think you're going to get rid of a lot of the problems that you've had historically. It's not going to be a slam dunk easy thing to do, because a lake like this and a lake like many lakes, it's death by 1,000 paper cuts. There's a little bit here, a little bit there. There's not going to be one smoking gun where you're going to say, well, if we fix that, we're good. I don't think it's going to be like that. I think it's going to be a little bit here, a little bit there. So that's kind of the way to think about that. All right. The phytoplankton population, I think that's worth doing. You guys, this is a figure 6. It's worth continuing to do that, because you do want to know if you have cyanobacteria or not on any given day, and every time it blooms, you want to find out what species they are. There are some volunteer programs where you can actually look at cyanobacteria yourself. I don't know if anybody has gotten involved in that. Have you dug at all?
Not in it, but
The
we
cyano-
have started looking at it through a microscope.
Yeah.
I don't know that program. What is
It's
it?
called Cyanoscope,
Okay.
and it's run by EPA and UNH Cooperative Extension. For a modest investment, they set you up with a scope and a digital camera. And the advantage is, you don't have to know how to identify everything that's in these samples. You can take pictures of them and send them out to a whole list of people who do know what they are. And pretty soon, on a lake, especially on a lake like this, there's a couple of bad actors, and you're going to know how to recognize those right away. So you can take a sample without sending it through the state lab, and if it happens on a weekend, you don't know what it is. You don't know until the next week or next month or whatever. You'll be able to throw it under a scope, say, hey, this looks like a bloom. Throw it under a scope, say, yep, this is one of the bad ones. And then you can act on it almost immediately, and without waiting for results. So, if any of you are savvy scientifically, you don't have to be that savvy. It's pretty simple stuff, to get the pictures and send them along. And if you have high school aged kids, they would be great to do something like that and take a look at samples. So.
Well, when you say act on it immediately, what do you mean?
So if it's one of that has been a toxin producer out here in the past, you might want to say, hey, we need to post the lake now.
Oh, okay.
Or conversely, if you think it might be a toxin producer and you look and it's like, yeah, I'm not seeing anything here that's a problem. We're okay. We can, so there's no guesswork involved there.
So just to note, so that everybody's on the same page, last week of May, we had a bloom. I sent pictures to the New Hampshire state, Amanda McQuaid, and she said, yes, it's definitely cyanobacteria again. So the same thing that was producing toxins in our water last year is already blooming this year. And so people need to be cautious about pets going in the water, pets drinking the water, or kids swimming if there's a bloom right near them.
Where did you see the bloom?
It extended from the southern shore all the way up past the middle of the pond. It was about 5 inches to 2 feet below the surface. But then since then, I've also seen it floating on the surface as little speckles.
Okay.
Yeah, and Amanda's great, but she is busy in the summer. So, by taking charge of it yourself, or at least part of it, you don't have to be the absolute expert, but you can at least take pictures.
Yeah.
And you're going to start seeing the same things over and over again. There's a cycle to this, and
Is there a way that you could take like a pumping and filter system and suck it up and filter it out of the pond?
yeah. So probably not. I mean, I've definitely gotten this question before, and it's not a crazy thought, but it takes about 4 or 5 days for a bloom to get going and to filter the whole.
I mean, it's like if it came across and you sucked up like a wet dry vac with filters.
Yeah,
Like
I don't think
back
you
out
could
after?
do it. I don't think you could do it quick enough to make a difference. I don't think you can get enough of it to make a difference, even on a small pond. I know that was suggested on a lake that I'm working on that's maybe twice the size of this, and we did some quick calculations and decided you would need something like a wastewater treatment plant to actually be able to effectively treat it. And nobody wanted that on the shoreline, nor did they want to pay for it.
So we have the bloom, but it's not showing on the state website.
Right, so Amanda was gonna come out and take her own samples
Oh,
to
okay.
quantify it.
Okay.
Based on the pictures, she said it's over 70,000 cells per mil, and so she was saying that it's over the limit where it will be posted. She just hasn't gotten
So
it.
there's just gonna be a lag time.
Yeah, right, as he says, Amanda's busy.
Yeah, and she's going to get busier.
Yeah.
We get another couple hot spells like we've just had. She's going to be really busy this summer. So the two species that you've had, both of them are capable of producing toxins. The two primary cyanobacteria. So those are ones that you're going to want to know how to identify quickly and be able to know if that's what you got. Oftentimes things like pollen look like a bloom, but they're not, and you can tell that pretty quickly if you throw it under a microscope that it's not a bloom. And you guys have a lot of alert eyes, meaning Doug and Bryce and many others. You guys are looking, and that's I think one of the side effects of the pandemic is that there's more people around our local lakes than there ever have been, and people are saying, "Well, I never saw that before." It's like, well, you were never here all summer before, but there's a lot of eyes, and that really helps. I talk it amongst yourself. If you see something different, keep the conversation going, because that's how you find out about things, and that's often how I find out about things. I mean, I can't sample every lake, every day, and people will call and say, "We have this going on. What do you think?" It's like, okay, I'll come over and take a look, and I never would have caught it on a weekly or even monthly sampling program or anything like that. So, all right. So I think one of the unanswered questions, I'm going to go kind of skip ahead to table 5. I already talked about phosphorus concentrations and where you're at now. So there aren't a lot of oxygen data for this pond, and under low oxygen conditions, so you have a situation where plants are at the surface, algae are at the surface, and they make oxygen, right? Photosynthesis, they use carbon dioxide and they make oxygen. As they die, they sink to the bottom, out of the lighted zone. So there's not enough light down there to make oxygen anymore. So they rot, just like something that you left in the fridge too long. And they start using oxygen at that point. So if you have too much productivity, too much green stuff on the top, you end up with too much rotting on the bottom, and you use up all the oxygen. Under those situations, all of that phosphorus from loadings past for a millennia can come out of the sediments and get circulated back up into the water column. And that's the situation that we really we don't know enough about here. There's a little indication, like this profile or this oxygen data was from 2015, and there was virtually no oxygen near the bottom. I think we need to know how often that's occurring, whether it's occurring every year, and for how long it occurs. Does it start now and go through September? Is it only in the middle of August? But that's really important data to know. And so the piece that you want to know in addition to that is, if there's no oxygen near the bottom, what's the phosphorus concentration in that water down there? Is there phosphorus coming out of the sediments now? Not all lakes, even if they have an oxygen problem, will release the phosphorus. Some have enough aluminum naturally to hold the phosphorus there, but some do not. And we just don't know the answer to that question right now. We don't know, and the easiest way to get an indication of it is, when there's no oxygen, get a phosphorus sample down deep and see how that's different from the phosphorus at the surface.
I have a question about that.
Yeah.
When I'm a current volunteer sampler, and the state has guidelines for us to determine the depth of the upper layer sample and the bottom sample, and we're usually 18 inches, maybe a couple feet off the bottom. But if I look at the DO profile.
Yeah, right,
from
it's
last
close.
August, you know, we might be right on the fringe of that. where,
Right.
Like we had DO depletion.
Yep,
So should we be collecting a third sample
yes.
to meet your suggestion?
Yes, and so I'm not going to advocate, not collecting what the state is looking for, because you got a long history there and a long data set, and that's very valuable as well. But I think this is a unique enough situation that taking a third sample, I mean, they cost about 15 or 20 bucks a sample to run. This is small potatoes for the amount of information you're going to get from it.
Sure.
And if you can get it, you want to get it without collecting any sediment with it. That's the trick.
Right.
Because if you even get a little bit of sediment with it, your phosphorus concentrations are going to look really bad. And they may not be as bad as that. You want just the water. So if you have to let the sample go back, if you pull it up and it's like, there's a little bit of sediment in there, get rid of it, collect another one. But I think that's well worth doing.
Okay.
Anytime there's no, virtually no oxygen down there, collect one of those deep samples. I think that'll tell us a lot
Okay.
about what's going on. Okay, so table 6, I did a really rough modeling of the lake, and this wasn't part of what I was originally going to do, but I was locked in my basement in the pandemic, and in November there wasn't a lot going on, and it's like, well, I could just sit here and twiddle my thumbs, which I wasn't probably going to do that, but I was curious as well. So I said, all right, let me try to do a little modeling here and see where you're at. And I wouldn't publish any of these numbers because I don't think we have enough data behind them to be sure of them, and that's why I kind of gave you ranges. But if I was to guess, I'd say, maybe a third of what you have out there might be internal, maybe another third might be septic systems, and the rest might be kind of land runoff with a few other little sources in there. There is a certain amount of phosphorus that comes in from the atmosphere with rainfall and dust and things like that. There's not much you can do about that. That usually comes from farther away, although things like leaf blowers and stuff like that can create local dust, and all that dust has nutrients with it, and if that ends up in the lake, the nutrients go with it. So those are local sources of dust that you can control, but most of the atmospheric sources you can't do anything about. But the rest of them you might be able to do something about. The internal loading, if we determine that's a problem, and we don't know the answer to that because it's just not the data to support it. But if that is the problem, there are things that can be done about it.
Internal, what is that?
That's sort of coming back from the sediments. So that's when,
coming from the sediments.
yeah.
Okay.
Waterfowl, you can definitely do something about that. You want to, you don't want any more waterfowl than would naturally be here. Those are fine to have. They're part of the ecosystem, but you don't want to feed ducks, you don't want to feed geese, gulls, things that aren't supposed to be here, or in numbers that aren't supposed to be here, you don't want here. As I was saying before, and some of you were here, waterfowl excrement, if you've ever seen the goose poop on the lawns, which everyone has, that's like crack cocaine to algae. I mean, it's like you can turn goose poop into algae, in a couple days. It's really, really available stuff. There's no breakdown required, and so it's not what you want to have happen. Septic systems, in addition to being a potential nutrient source, are a public health problem if they're not working. If they're not working properly and they're going into the lake, that's a bacteria problem and a health hazard, and there's a lot of reasons to make sure your septic system is up to snuff. Besides the inconvenience of not being able to use your plumbing inside the house. And the watershed load, those are things like gravel roads, people's lawns, roof runoff, all the hard surfaces in the built environment, and things, places where water goes over the ground and picks up soil and continues onto the lake, as opposed to going into the ground and filtering through leaf litter. And there's very little phosphorus gets out of an intact forest, but there's a lot of phosphorus that can get out of developed areas and built areas. And where where you know, it's unavoidable. We live near lakes, right? It's unavoidable to have developed areas. But if you can direct the runoff to a wooded area rather than directly to the lake, that's really helpful. You know, and those are the kinds of things that, you know, like a soak up the rain program, which you know, Sarah's you're gonna look into that, or the New Hampshire Lakes one.
Yeah.
And yeah, great. And those are both great programs. They'll come onto your property and just talk to you. And it's not an enforcement thing. They'll just say, hey, you could probably do this better. And here's a simple idea. None of these are really expensive ideas. They're things with a shovel and a wheelbarrow you can do mostly yourself. And but they can make a big difference. Like I said, this is probably 1,000 paper cuts around the lake that are adding to your you know, phosphorus numbers here. The other thing that I like to encourage people to do is take a walk around your property when it's pouring rain out, just pouring, and find out where the water's going and what's happening. You will learn more on that about what's happening on your property than anything you could ever read. And if you see dirty water going down into the lake, figure out a way to fix that, you know, so that doesn't happen the next time. You know, put on a rain jacket, and you just got to get out there and slop around a little bit. And the same thing goes for your roads. You know, with gravel roads, they're notorious for washing out. And, you know, a question I always ask, you know, when I'll talk to you know, lake associations, I'll talk to road associations, and, you know, they'll say, well, our road's not a problem. And I'll look at it, and it's like, that looks like all new gravel in there, you know, and I'll say, well, how many loads of gravel did you put in this year? So, well, we put in about 4 loads a year to fix the road in the spring. I said, well, where'd the 4 loads from last year go? You know, and the answer is always, well, they're in the lake. You know, they went downstream into the lake. So, and that's almost always, you know, what ends up happening to them. So it's just a matter of, you know, properly having a crown on the road, and there's a lot of information out there on gravel road maintenance, and you know, you have pretty low impact roads here. They're pretty small, they're narrow. Obviously, I don't need to tell you guys that, but you know, they've even got they got vegetation growing right up to the side, which is all good. You know, it's just something to keep track of, and you'll see, you know, when it's raining, you know, if there's dirty water coming off it, figure out a way to trap that before it gets to the lake.
So Don, what do you mean by dirty water? You said to go out in a rainstorm, look at your
Yeah,
property.
turbid water, you know, water that's cloudy.
Water with leaves in it and all that, because the leaves contain phosphorus.
They can contain phosphorus. Leaves are a lot less problematic than soil.
Mm-hmm.
Soil is kind of the big thing because there's a lot of phosphorus attached to that. So that's you know, if it looks dirtier than the lake water looks, then, you know, you can probably do something to make it look better.
Done with the septics leaching into the lake.
Mm-hmm.
There's no other way to test I mean, essentially you're pooping in the lake. So
Right.
there's no other way to see like a coli or anything that other than and I know phosphorus is heavy in
Yeah,
poop,
so
but
I mean, in a really, really bad outbreak, a really failing system. Let's say you had your system was an old 55-gallon pail sitting on a granite rock, you know, lightly covered with a few leaves, you know, and it goes through a crack in the rock and right into the lake. You'll see the bacteria there. A little bit of soil contact, and that bacteria might not make it to the lake consistently. So that one's kind of a hit or miss as to whether you're ever going to, you know, see that. You got to be there like right after the flush to see it.
to go into it. But so the water itself dissolves. How does E. coli leave? I mean, where does it go?
Yeah, so it's
Because a lot of times it's like a bathtub. There is no leaving of, you know, I mean, the
in
dam is
the
dry.
septic system.
No, I mean, when you have a failed septic and it's going into the lake and it's been
Right.
going into the lake for years, how
Right.
come we don't have any other like effects in the water?
Yeah, so the
Or
E.
can you-
coli, I mean, it has a lifespan, you know, so it won't last forever.
Does the UV burn it off? Is that
UV can burn it off, you know, and so if it's just a periodic source, you might not ever see it. But the other thing is you're probably never looking for it either. You're never testing for it.
So essentially, all that's left is phosphorus, and ends up at the bottom. And
Yeah, and the phosphorus is much more soluble, so it ends up it sticks to soil pretty well. So if you have a properly functioning system, it'll go through soil filter through soil, and the phosphorus stays there, and then just the water moves on. You know, so a properly functioning septic system should capture most of the phosphorus.
Is there any way to identify, like, when you do, like, say, a soil sample, can you identify what's coming from the ground and what's coming from human fecal matter?
So you can do that. That's not an easy test to do consistently across a bunch of septic systems, because they're all different.
Because I mean, we got 52 cabins on a 54
Yeah,
acre
yeah.
pond. I mean,
And I think probably the first step is probably, you know, if it isn't a new system, have it pumped and have it inspected by a septic inspector that will tell you whether or not it's functioning correctly. If you see obvious signs of breakout, you know, let's say a mound system where it's always wet, even though it's not rained in a long time at the bottom of it, where it's breaking out, you know, in the bottom of the mound, and that ends up running directly into the lake, you know, that's a sign that it's failing. But a good septic inspector would see all of that.
no, I mean, like the, say, 20 years of just abuse from the lake. Is there any way to determine that the abuse is coming from
A particular system.
The way you got this defined is just based on topographical, right? I mean, just what you saw.
Based on the numbers of systems, and and I think so. Doug and his committee pulled together a septic survey, and that's going to give a lot more information lake-wide as to sort of what the numbers are. But system by system is still going to be get your system inspected and see if it's working right or not. You can tell a lot and make assumptions based on the age of system, with, you know, whether or not they're working. And I would say any system that's more than 20, 25 years old, you probably want to have it inspected just to see what's down there, you know, kind of before there were records. You know, a lot of people just don't know. They just have no idea. It's just, it goes away, but no idea whether it's functioning properly or not.
I had to sign a contract with the state when I had mine put in,
Yep,
that I have mine inspected every 2 years.
yep. And how long ago was that?
2 years.
8 years
ago.
8 years, yeah. So you were within that, like 20, 25 years.
Yeah.
The ones older than that, you know,
2 years.
a lot of folks just don't know.
Do they charge you?
Yeah.
Sure.
There's a place in Kretchmer that does it, and I think it was $210 last time. It went up, or $20. It went up $20, but
Where do they inspect your leach field and your septic, or just your septic?
well, I've got a triple chambered tank,
Oh, you have
and
a
they did
clear.
samples in all 3 chambers
Yeah.
just to make sure.
I gotcha.
That's
Do
great.
you have
I
the
mean,
new kind that does not have a leach field?
I've got a 5x15 leach, but I got a triple chamber with meteor in the middle,
Yeah,
and I got an air compressor that pumps and regurgitates it and keeps oxygen in it so it decomposes faster.
right.
You
Yeah,
have a
that's a great
special
system.
system for special circumstances, right?
Yeah, because
Gina,
I,
who is there?
the state requires 75 feet from the water. I couldn't get any closer than 73. So it was like they gave me 3 options. They go, I can guarantee the first one they're going to deny, the second one maybe, but the third one they'll accept. And I says, well, let's just do the right one the first time. I don't
Yep.
want to go over this again.
What was the name of the system?
well,
He says the 3
that's a good attitude.
It's got the clean water
Is
solution.
it the
Well,
clean?
when we used to have an outhouse, then we had a propane burning toilet, then we had a composting toilet, and I got sick of shoveling every year, and I said, if I'm paying for it, it's getting, I want to flush.
Got the Incinelat.
Is that the
Gotta
clean
drill it.
solution that you put in? Is that what
Yeah.
it's the clean solution?
Yeah,
Yeah, we've heard good things about that.
That's what my dad's doing. Yeah, it's the same thing. He's got to have it inspected.
yep.
Yeah, because you've got the active oxygen pumping, they gotta make sure that that continues to work.
They check your air compressor, they do samples in all 3 chambers and everything.
And invented right here in New Hampshire.
Yep.
So just a general comment, I mean, that's great that you have such a good system. I think 5 people on the pond are getting new septic systems put in this year, which is, that's wonderful, you know,
Yeah.
updating them and really doing it.
Yeah.
That's a real step forward, but we all need to check it. I think you said to me, correct me,
We also deleted
that
the gray water-
even a well-tuned,
the gray water-
relatively young septic system catches 90% of the
That,
phosphorus.
I mean, that's
and
a
about
general
10%.
assumption, yeah. That
10% still gets to the lake.
still can get through, yeah. And it, you know, a lot of that depends on, you want it back as far away as you can from the lake, and the further away it is, probably the better it is in terms of, you know, it's got more time to drop the phosphorus out. But that seems to be a pretty accurate number over a whole bunch of lakes, yeah.
And then 25 years old, well, it's
It might
releasing
be
about
more like-
twice as much.
Yeah, might be more like twice as much, right?
And that's a well-working system that's
Right.
in perfect shape.
Right.
So,
I mean,
no,
part
we've
of
gotta
the
make
old
sure there are not bad systems.
right, and part of the older systems is, you know, the leach field gets clogged, so it doesn't, you know, with things like grease, and so the soil gets clogged with grease, and then the water can't flow through there, and the phosphorus can't get grabbed onto the sediment particles, and that's often a reason why, you know, systems fail over time.
With detergents too.
Yeah,
I don't know if you guys watch dryers.
Even a phosphorus-free detergent?
I don't think there's such a thing. Is there such a
Yeah,
thing as
there is.
phosphorus? Isn't all soap bad?
no, I mean, there
Also
is
spend the water.
phosphorus-free detergent, and a lot of them are now, and that's, I would definitely recommend doing that, using that. You know, I would also recommend, if you have a septic system, which everybody does here, you know, not using a garbage disposal, because that adds an awful lot of solids. You're gonna pay to get rid of that stuff eventually. I mean, you put all those solids in your system, you're gonna have to get it pumped more often, and there's no reason to not take that and compost it elsewhere and grow your flowers with it. But better than putting it down in your septic system. That just adds a lot of unnecessary phosphorus. So, okay, so I have quite a bit of guidance that maybe would be better with a smaller group talking about, you know, monitoring, water quality monitoring stuff, and that might be a better conversation for a smaller group if there's questions about that. I mean, rather than the big group, and I kind of want to spend a little bit of time with some of the bigger questions, sort of, or the bigger action items. So I have some specific investigations that I talked about in the report, but I kind of want to go to the management section, which is kind of more appropriate for the bigger group. So the first step there is the monitoring, and I've got a lot of monitoring guidance that I put in this audit, and I think, you know, it's important to get good data before you jump to the next step. You know, regardless of what you do, you need to understand where you're at before you can kind of figure out where you're going. And there's some holes in the data collection. It's great that you have data back a long ways, but now we got some specific questions we need to answer, and we tried to set up the data collection so that we can answer some of those. And you know, once you got into bloom territory, it was like, okay, you know, we're out of surveillance. Now now we got to figure stuff out. So anyway, that's the first recommendation. The second one is, you know, kind of the aggressive watershed management stuff. I do recommend in here that you guys do a watershed plan. I think it's really important, and what it does is it gives you a blueprint for how to go forward, and it prioritizes which areas are important. But even more importantly, it gives you the ability to apply for grants to fix things, you know, some of the bigger things. For example, you know, we were talking about this before. I've been working on Nippo Lake for a number of years down in Barrington. They just had an in-lake treatment done. They got a huge grant from EPA in the state to do it. But the only reason they were able to get that grant is because they did a watershed plan and figured out where everything was coming from and have a plan of attack for fixing everything. And they had fixed a lot of their watershed issues first, so then they were able to go and deal with what's in the lake. I'm not saying what they did there was necessarily the appropriate thing here at all, but it might be, who knows? But we don't have enough data to say one way or the other at this point. So a bunch of the things are the simple things. You know, the watershed management is just simple things like vegetative buffers, infiltrate water wherever you can, rather than run it off into ditches into the lake directly. You know, send it into the ground. It'll make it to the lake eventually, but it'll be a whole lot cleaner if it goes through the ground first than just pipes directly to the lake. Discourage waterfowl. Deal with pet waste. Keep that, you know, away from the lake. Do the Soak Up the Rain or Lake Smart. I think that's a really good program, and it's free. And you know, once you do a few of them, people are like, oh, geez, I like those ideas, and it feeds upon itself. And that's that's maybe even more valuable than having being the first or second person that does it. You have a showcase property that people can say, I got that problem in my house too. What can I do? It's like, well, so and so just did that over there. Go take a look at that. And it kind of feeds on itself. You guys are doing a great job with education and outreach. Keep up with that. I mean, the fact that you have thick folders for today, you got a lot of homework to do. It's all good. Do a plan. It doesn't have to be anything too elaborate. I think the plans now are a little simpler than they used to be, and especially for a small lake. I don't think it's not a huge project to do, but it's a good touch point to kind of pull all the elements together in one place. Like, these are the things we need to do, and this is the schedule we need to do them on, and this is what it's going to cost. So I think that's a really useful thing. Part of that plan will be coming up with a goal. I think your goal should be somewhere below 8 micrograms per liter for phosphorus, which is probably on the order of 20% decrease from where you are now, maybe a little more than that, but I think that's doable.
Would that be done with treatment or
that
just
that
awareness?
would be done probably with land-based stuff.
No
start.
additives?
No additives yet, until we know for sure that there's an issue out there. Yeah.
And calculated how
Band-Aids
it's a deep spot, certain level, or
So
average?
you calculate it basically by modeling how much is coming off the land, and that's part of the planning process.
No, but I mean the 0.8. You're shooting for the 8.
Oh, 8, yes, that's out in the middle,
spot.
deep spot, yes.
Okay.
Concentration, annual average.
Annual average, okay.
Yep. So modeling, I mean, doing a calibrated model, once you get more data, that'll be much easier to do. You can't really do that right now. Number 8, I want to spend a little bit of time on that. Continue protection of as much of the watershed in a natural state. You will not find a better practice than that protect this lake than keeping the hillsides around it forested and in kind of a natural state. And I'm not going to say never develop anything, never build another house in this watershed, because that's just not realistic, and we have to live somewhere, and we all like living around lakes, and there are other people who want to live around lakes too. But when you do build with a very small footprint, as small a footprint as you can, and I don't mean necessarily size of the house, but no grand lawn, near the lake, do it as carefully and thoughtfully as you can, and make sure that you have as much infiltration as possible. It's much easier to do that when you're originally building a place or rebuilding a place than it is to try to fix it after you've built something. And likewise, the hillsides, if there was a 30 house subdivision proposed up the hillside on steep slopes, that could be a big problem for you guys. Your tributaries look real good right now. A lot of the land up there is already protected, but identify which parcels aren't, and think about getting somebody interested in protecting them.
We're doing a collection later.
Yeah. Well, a lot of times it's in a lot of watersheds that I work in, it's just a matter of approaching the owner, and a lot of times these are families that have had it's been in ownership for a long time, and they would like to preserve the legacy, and you can figure out a way for a land trust to take it over and them to get a tax break on the estate, and they can still use the land, but it's got a conservation easement forever. And there's lots of people that are much better versed in that kind of land protection strategies than I am. But there's a lot of land trusts around here.
I think everything around us is pretty much in trust, just a matter of what they end up doing with it later.
Is 100+ acres that's all been bought up and locked into current use.
Yeah, and I think that would be a really good exercise to kind of look through the tax maps. And
Oh, we
see
did,
who owns.
yeah.
There's an app
like this
that tells you
400 over
everyone.
here, we know we're all.
Yeah, that's perfect.
And they're all in trust, and they're all in fish and game management if you have over a certain amount of acreage.
Yep.
And then a lot of these guys own behind here. Obviously, they're not going to build or anything like that. Just,
Yep.
So it's pretty well locked up.
You gotta get Sawyer Hill though.
That's
She lives in New York. So it's hard to. Got plenty of money.
Yeah, so that's great. That's exactly the kind of forward thinking you need to have, because I work on a lot of lakes that are, moving along just nicely, and then all of a sudden somebody buys a parcel of land, logs it, and puts in 100 house lots, and it's almost, I don't want to say it's game over, but it's a whole lot harder to keep the lake pristine if the hillside's blank, bare, and there's a lot going on. So
Yeah, it's because there's hills, so yeah.
right. There is a lot of reason to be hopeful here. I think you guys have a lot of things going for you here. I think where you've been would suggest to me that this could be, a really high quality lake again, without the algal blooms. And it's going to take a little bit of work. I'm not going to, suggest that this is going to be a quicker, completely painless process. And it probably won't be free. But I don't think it's going to be ridiculously expensive. I don't see anything that's like, oh my God, this is going to be, overwhelming to fix. It's going to be a lot of little steps to start, and then identifying if there are any bigger steps that need to happen. So, I mean, that's kind of questions. Yes.
Sorry, this is probably a stupid question. Leaves at the bottom of the pond.
Yes.
It's always been a tradition that people go out and they rake, their beach areas, they
Yep.
rake their swim areas. And I'm on the north end with the marsh, where all the leaves seem to flow in the fall.
Yeah.
Yeah, lucky me. But, yeah, I know you do too. But, I mean, it's like, so do I rake them out? Do I not rake them out? What's the verdict?
Kind of the guidance is, I mean, there's been leaves coming into these lakes forever. They decompose fairly slowly.
Yeah.
As long as they're just the leaves that naturally fall in the lake, that's okay. They're okay to be there. They're there's a lot of bugs that, beneficial bugs that depend on that leaf litter to grow up and, create dragonflies and things for fish food, and it's all part of the natural system. If you're raking your lawn or raking out the woods and throwing the leaves in the lake, that's not so good. And I've seen that happen. I've seen leaf blowers, people blowing leaves into the lake, blowing,
And there is a handout in your folder regarding that.
yeah. I've seen people dumping grass clippings into the lake. It's just, it's crazy what people, kind of think is okay. But if it's natural leaves, it's not detrimental to the lake. In fact, it's probably beneficial.
Yes,
but is
raking them up bad?
Raking them out, well,
Yeah,
I mean, you need.
People don't want to step on me.
Yeah, no, I understand
If
that.
you go near my dock on one side, I mean, literally, you will sink down to
Yeah.
your knees
That's
in
the
mud.
natural part of the pond, Susan.
Right.
That's how it always was.
Oh, I know, I understand that, but I mean, there's also, I've got a 2-inch layer thick of leaves from one every year.
Yeah, I think it's a, if it's an access thing, if you can figure out a way to do it, make access with as little a footprint as possible. It's like the same way we think about the land, with as little footprint as possible, then that's the way to go.
Okay. I mean, I don't have a problem with not raking them.
Yeah.
But I also know that then there's less water. My water level is shallower, and
Right.
the sun, right?
Does
Right.
that release phosphorus if you
Very,
rake that
very,
up?
yeah, very well. If you break it up, so what can happen is, anytime you disturb the bottom, either by raking or whatever, you're creating a fertile field, and it's similar to if you created a bare patch in your lawn, the first thing that's going to grow back are things that you don't necessarily want. So, and they may be invasive species, they may be plants that you don't want, and I think the less disturbance you do, probably the better. Disturbing the layers. By just disturbing the layers, you end up moving a lot of solids back into the water column. I mean, it gets cloudy. The water gets cloudy. There's phosphorus in those particles that are in the water, and a portion of that dissolves. That can fuel more algal blooms and things like that. So, if it's a natural phenomenon, I guess I would err towards leaving it be. If it's an access thing, where you just, have a little pathway you want to get in, you need to move this, or, that's probably okay, but, taking, the whole shoreline or large sections of lake and trying to clean them up is probably not the right action. If that makes sense.
I have a question from someone who couldn't be here today, so they just emailed it to me. So they're talking about, like, a lot of times at their camp, even if there's an alert, the water has looked clear. So his question is determining whether it's safe to swim as simple as looking at the water to make sure it's clear, or is the cyanobacteria toxins likely present and dangerous even when we can't see it?
Yeah, so I think if this is a small enough pond that I think, the first step is it clear? Do we know of a bloom anywhere in the pond? Like today, I don't think that there's a bloom going on, right?
No, right, don't know
Right.
right now.
Probably okay today, on a day like today. If there's a bloom in the other part of the pond, it just happened the wind's blowing in that direction. These toxins, as the cells die, the cells fall apart and the toxins live on. So they can be in the water, even after the bloom or where the bloom isn't. So if the bloom was on your shore one day and some of the toxins, some of the cells died and the toxins released, and then the bloom blew the other way, the toxins might still be there. So I would say if there's a bloom on the lake, I'd be pretty careful. I mean, I guess I tend to defer to what the state's guidance is on whether or not it's advisable to swim or not. But basically my thing is if I can see a bloom that's somewhere in the vicinity, I'll probably not swim. Err on the side of caution, particularly if I know it's a species that can produce toxins.
So how many days after the bloom we can't see it anymore? Because obviously.
Yeah, right. Again, I would kind of defer to the state. I mean, I'm guessing it would be a matter of days to a week, but I don't know for sure. It kind of depends on the toxin.
On how much boats is stirring it up and loosening it up.
Right.
What about the test?
Yeah, so there are some tests that can be done, some rapid tests that can tell you whether a toxin's present or not. And I think that might be something that might be worth talking to Amanda about, what she knows about those. And if you want like a yes or a no answer fairly rapidly, you might want to invest in some of these quick tests. You could test now and the wind direction could change and it might be different in 20 minutes, but you could potentially test, several different places around the lake and say, hey, we're looking pretty clear today.
So one issue there is that we've got a couple of species of cyanobacteria,
right,
each of which produces a couple of different
toxins.
toxins.
That's right.
And we might have to have multiple.
You might. I mean, I think I would
pretty quickly.
I would maybe start with the test that like the microcystins, which is in both the species that you have, and it's a fairly more common toxin. So that might be one to start with, and see whether you find the test reliable. I mean, if you put it in in the middle of a bloom that is toxic and the thing doesn't read toxic, then well, maybe this one isn't quite ready for prime time. But try them out. You may even get the companies to send you a test kit or something, just to try it out. Say we're interested in putting together a program, but can we try them out first and just see whether we find them easy to use or not, but I think if you get a positive test, then that's worth sending a sample to the state and getting something more quantitative to see what the actual level is.
I have a question.
Yeah.
What about, people have been talking about this. What about just jumping in, swimming a little, and then taking a shower?
Well, I think that's probably a reasonable thing to do if you don't know anything about whether there's a bloom or not. Some of these cyanobacteria are skin irritants as well, and they can be absorbed through the skin. So even ones that are fairly benign, like Leotrichia, which we have in a bunch of lakes in the lakes region, can be pretty irritating on the skin. You can feel pretty itchy afterwards. So
Do the toxins enter the skin?
I'm going to defer on that question. I think so, but I'm not positive.
But a lot of people pump from the lake too, so it aerates it. So you're breathing that in.
Yeah, and that's probably not a good
probably
thing.
more dangerous than swimming in it.
That's probably not a good thing, particularly if there's a bloom going on, which would, suggest even more if it's your water supply for showering and things like that. Having some routine testing would be really a good thing to do.
Yeah, or drill a well.
Or drill a well.
If you get that kind of
Exactly. So I'm not, I don't live far away, and I'm only only electrons away from you guys. I'm glad we could meet in person, and now that I think pretty much everyone's vaccinated, and myself included. So I'm glad we could meet in person, and yeah, it's been great working with you guys up to this point. And if there's a role for me going forward, great. I try to steer lake associations towards either doing the things that they can do themselves or getting free help where they can get it, like the Soak Up the Rain, because I realize there's not a lot of resources, that people aren't saying, geez, I got an extra, couple $1,000, where can I possibly spend it? People aren't in that mode, and a lot of the things that I think that probably need to be done, at least right now, are cheap or free. The testing, you guys can do that yourself. That's cheap to do or free to do. You got to pay for the tests. But a lot of the Soak Up the Rain stuff is free and or just about. So go for it.
Do you do the soil sampling?
I do sediment sampling in the lake, but I don't do soil sampling on land.
No, I mean the sediment sample. Wouldn't that be the next step for us?
I could do that. I'd really like to see, what the oxygen issue is out there, and I think that's going to be really important. But doing sediment sampling is something that I think would be useful to know how the phosphorus in your sediments is bound.
Because you can't add oxygen, right? You just have to lock the phosphorus in. That's the only option we have.
You could add oxygen, but you have such a small layer, and it's a shallow lake, that it's a really inefficient process.
It'll rise right up.
Yeah, I mean, you're releasing bubbles at depth, and the bubbles are still bubbles by the time they get to the surface, so a lot of what you're introducing doesn't have time to dissolve. So it's not real efficient in a lake your size.
So ours would more be locking.
It might be more locking, if that turns out to be where your phosphorus is coming from.
We're looking forward to having you do the sediment sampling.
Yeah.
As you can fit it in.
Mm-hmm. Like I said, the sediment, that one's not time critical in terms of, sediments aren't going anywhere. They've been there for a long time, and hopefully they're not, nobody's digging them up and hauling them off or anything, and you're not accumulating them that fast, so it's not going to change whether we do it now, later in the summer, in the fall, next year. I mean, all of that is all going to give you basically the same answer. So,
Don, I know it's not the deep core thing that you go down, 20 feet in
No.
the core, but how far back in time does that sediment
yeah,
sampling-
so it depends on how quickly it accumulates, but I think if you can do like about a 4 inch, the upper 4 inches, that's usually the level that is active to get back into the lake. Anything deeper than that doesn't readily go back into the lake because it's buried deep enough. So depending on how what the sedimentation is, that could be 100 years worth, or in a rapidly sedimenting system, that could be 4 or 5 years worth. You're not in that category. I'm guessing you're in the 50 to 100 years is 4 inches of sediment, somewhere around there, maybe more.
A lot of information, just a
Yeah.
shallow.
Yep.
Yeah.
And what we'll do is, for the initial look, we just mix that whole 4 inches up and send that as one sample, rather than trying to look at individual layers and figure out which year, it came from. That's all really interesting academic stuff, and you can do that, but it's somewhat expensive. I might be, if I get an opportunity, I can get an academic interested in doing that for nothing. I'll steer them your way. I have done that. I have been able to do that in the past.
Well,
I got this really interesting lake.
We raised money to do. Isn't that what
Yeah,
the
no.
focus was?
Yeah, sediment sampling. We're talking about core sampling.
Oh yeah, no, yeah. I don't want to don't really care what.
Yeah.
Yeah, we know there's sheep.
So,
Right.
Don?
Yeah.
So therefore, you're gonna go down in just the deep spot?
Probably 3 to 5 locations, and the upper 4 inches of sediment is what we'll target.
Okay.
Yep. And we'll try to figure out what's binding it and whether or not it can come out or not. That's the critical question. You know, if you're lucky, there's enough aluminum there, and whatever phosphorus you have down there won't come back to haunt you.
I've heard stories of years ago, they used to drag bed springs with boats. And drag,
Yep.
drag the weeds out.
They did that in a lot of lakes.
That was for the bladder wart.
Yeah. Yep. There's a lot of lakes had that.
That
You know,
work?
Does that do anything, or is it?
Well, it stirs up the bottom, and those sediments, you know, release some phosphorus when you do that. So, but I mean, it will cut the weeds. You know, and you know, there's, you know, stories of people dragging a cable across, you know, winching a cable across the bottom and cutting all the leaves off and all the weeds off, you know, and all kinds of stuff. Yep.
So it sounds
It's
like
all been tried before.
basically not stirring up the bottom of the lake.
Yeah,
It's a good thing.
Yeah.
Yeah.
So you said before, when we were talking, that if it's 6 feet, if the bottom is 6 feet down,
Yep.
then you shouldn't be using heavy motorboats or anything around that. But
Right.
other than
Anything
that-
less than 6 feet, you know, you're probably going to stir up. You know, if you gun it in 4 feet of water, you're going to stir up sediments.
And you gun it in 6 feet, what happens?
It's probably better. I mean, it won't. That big swirl won't get to the bottom. And I don't know what size boats you have here. Probably
Right.
not.
You probably won't want to gun it in 4 feet of
Probably
water.
not
anyways.
enormous ones. What's that?
You probably won't want to gun it in 4 feet of water anyways.
Yeah. Right. Right.
So the size of the engine is important, right?
Oh yeah.
Yeah, tell us about the size of engines.
He knows everything, right?
Yeah. I don't know everything about that. I mean, the bigger the engine, the deeper the.
Well, I mean, we're not Lake Sunapee, so
That's
I
right.
mean,
Right. I don't know what's the biggest engine you
Well,
guys have out here.
We have 2 or 3 inboards, and we have maybe 3 or 4 outboards. The outboards the highest is 115, I think.
Mm-hmm.
The inboard side, they go higher, as you know.
Yeah, but they don't have quite the punch of the. I mean, 6 feet's a good thing to shoot for. If you find that you're gunning it in 6 feet of water and there's a big dirty plume behind you, go deeper.
Yeah,
I guess
you can
that's
see
the.
it when you're starting skiing.
I mean, you know, there's no hard and fast rule, but I mean, if you're making a mess,
Right.
stop doing it.
You can see it.
You know.
You can see it if it gets stirred up.
Yeah.
So just for context, the average depth of the pond is 6 feet.
Right.
So
It's kind of the middle of the pond is probably the only spot where you're not going to be kind of disturbing the bottom. Yeah.
yeah.
It's getting warm out.
Yeah.
Oh.
After
I was out all day Tuesday and Wednesday. Oh my goodness, on a lake. You know, it sounds glamorous, but man, it was hot.
Well, I do commercial HVAC, and I've been on black rubber roofs, metal roofs, white roofs all week, so.
People calling these days.
Oh, yeah.
Oh man, I can
haven't
imagine.
stopped for the last year and a half.
Yeah.
The pandemic didn't slow our company down at
Right,
all.
right. I bet.
Because of all the air quality and everything else everyone wanted, you know.
All right. Well, you guys have more business to attend to, right?
Yeah, a few more.
Good.
Well, thank you very much for.
Well, thanks, guys. I hope this was helpful. I kind of enjoy. I mean, I often have to do. You know, I'll do presentations of screens and slides, and I never know if people are sleeping or not. At least now I can see you all. The lights are on.
Thank you, John. That was excellent.
Yes,
It
thank you.
was very helpful.
Well, I'm not going far, so bend my ear anytime.
Okay.
Thanks for the water, Patrick.
Good
Good
job.
job. Good. Thanks, Aaron. Yeah. Doug, we'll be in touch at some point. I'll let you know how my schedule is working out.
Yeah.
I said I'm kind of